Next concept is a law called as Dalton's law of partial pressure. Dalton's law of partial pressure. I know that you have studied Dalton's law, where you have studied the postulates of Dalton's law based on the atomic theory. So that was the explanation given related to atoms. Now here Dalton's law of partial pressure, whenever it comes as partial pressure, it means it is in the gaseous state, and however you are studying about it now. For the gaseous state, which law was stated? So John Dalton, in the year 1801, he explained about the pressure of the gas. Now if you want to have a picture of how actually the pressure is exerted, however you will be studying one particular theory soon after this particular law. But before that, say you have a container now. In a container you have filled it with gaseous molecules which is closed. Now that container which is having gaseous molecules inside it, they hit with the walls of the container. That means they hit inside the container, hit each other as well as to the walls of the container, and so they exert pressure. Now Dalton gave idea that how you can calculate pressure. He said how you can calculate pressure. Partial pressure means pressure of individual gas molecules. Please make a note somewhere that partial pressure is the pressure of individual gaseous or gas molecules. Now say, I have told you, if there is a container, a closed container you take, there are many gaseous molecules inside it. Now each molecule will have pressure, isn't it? Each molecule is exerting pressure. One molecule will go and hit on the walls of the container, it is exerting a pressure. Second molecule goes and hits on the container, it produces a pressure. So each individual gas molecules means each gas molecule possesses or it is exerting some pressure. So the pressure exerted by individual gas molecule is called as partial pressure. Hope this term is clear to you. Now we will see what Dalton stated. Dalton said that, okay, now a container is given to you, and if you want to calculate the total pressure of it, how do you calculate? Can you just calculate, you just go and calculate as a whole? Then he said, see, if you want to calculate the total pressure of that particular gas, whole gas mixture, and that too a condition was told, a mixture of non-reactive gases. Non-reactive gases means which does not react with each other. So if one is any one gas, the other will be any other gas. So in a mixture of non-reactive gases, he said, the total pressure will be the sum means total of the partial pressure of individual gas molecules. That means you have to calculate how much pressure each molecule is exerting, then you can total it so that you get the total pressure, he said. Who said? Dalton said this. So total pressure is equal to, are you getting the point what I mean to say? Okay, we'll write. It states that, I'll explain you again. It states that the total pressure exerted the total pressure of a gas of a mixture of non-reactive gases is equal to the sum of partial pressures of individual gas molecules. This is the statement of Dalton's theory. See, what is the main point that you have to remember is the total pressure of a mixture of non-reactive gas. See, this term is again important. Non-reactive gas is equal to the sum of the partial pressures of individual gas molecules. That means now you have a container, you want to calculate what is the total pressure in this container. If you want to calculate the total pressure, add the pressure of each gas molecules, he said. That means if one is exerting a pressure P1, other one P2, P3, P4, P5, then sum all those. If there are 10 molecules, then P1 plus P2 plus P3 plus P4 up to 10 you will have to add the pressure of all the gases. Then you get the total pressure, he said. Hope you have understood. And why mixture of non-reactive gases? Non-reactive, which does not react with each other. If one is oxygen, say the other one is helium, they do not react with each other. In such cases, he explained how this total pressure can be calculated. Yes. So mathematically it is given as or given by the equation P total, that means total pressure can be calculated by taking sum of individual gas molecules partial pressure plus Pn. If there are n number of molecules, n number of gaseous molecules, then you can write the expression this way: at constant temperature and volume. At constant temperature and volume, mathematically we can write P total is equal to P1 plus P2 plus so on at constant temperature, where total pressure can be calculated by considering the partial pressures of individual gas molecules. If there are only 3 molecules, then P1 plus P2 plus P3 will give you total pressure. If there are only 5, P1 plus P2 plus P3 plus P4 plus P5, like that. Hope it's clear. So this law is very important. Most frequently asked question this is. That is state and explain Dalton's law of partial pressure will be asked. When they ask you to state and explain, then you will have to write the statement of this. Then you will have to write here, not directly writing. Instead you will have to write, if P total is the total pressure, P1, P2, P3, so on up to Pn are the partial pressures of individual gas molecules, then mathematically it can be given as P total is equal to P1 plus P2 plus so on up to Pn. This is how you will have to write if they ask you state and explain. Okay. So P total, I'll write it here. P total means total pressure P1, P2, P3 Pn are partial pressures of individual gas molecules. This is how you will explain Dalton's law of partial pressure. Hope I'm not confusing you. Now, if you have to, using this Dalton's law, if you have to calculate, or if you have to find out the pressure of a dry gas, usually what happens, say you have taken a closed container, you have a container which is closed. It has gaseous molecules also. There might be a possibility that some water vapors or moisture might be present. Along with the gas, there might be a possibility that water content or moisture might be present. So we say moist gas, because vapors also will be exerting a pressure downwards. You know that, isn't it? If these are gaseous molecules and here you have moisture, then those moisture also will be exerting a pressure here, which we call vapor pressure. On the surface. Now, if you don't want to know the pressure of moist gas, you want to know only for dry gas what is the pressure, then what you have to do, you have to see that, I'll tell you, there is one more term, please make a note of it, aqueous tension we call. Aqueous tension. Aqueous refers to water, tension refers to pressure. So what is it? Pressure exerted by water vapor is called aqueous tension. Make a note of it. Aqueous tension means pressure exerted. Exerted means exerted by the water vapor is called as aqueous tension. Now, sometimes what happens when we measure the total pressure, this aqueous tension also will be disturbing. That means aqueous tension also will be added there. We don't want that aqueous tension. We want only for dry gas. If it is only for dry gas, then what we have to do? I'll just write it here. So usually when we measure the total pressure of dry gas, along with that we have the pressure exerted by water vapor. What do we call it as? Aqueous tension. Now what should you do if you want only the pressure of dry gas? If you want only the pressure of dry gas, what you have to do? Then you should be able to calculate aqueous tension, pressure exerted by water vapor. Subtract that aqueous tension from total pressure. Therefore, pressure of dry gas is equal to total pressure, aqueous tension goes to the left hand side, minus aqueous tension. Make a note of this point, where you can calculate the pressure of dry gas by subtracting the aqueous tension value from it. I need not mention, isn't it? Here P1, P2, P3 we have written. P1 means what? As per this equation, PV is equal to nRT. What will be P1 value? P1 value will be N1 R T1 divided by V1. What will be P2 value? N2 R constant T2 by V2. Like that, the values of P1, P2, P3 will be, if you are asked to add it up. If you are asked to sum it up, then how do you sum it up? Then it becomes N1 plus N2 plus N3. Then RT by V will be common there, like that. Okay. This is what we need to know from this. Next, very, very important concept is the theory of gas. I'll just introduce you what actually the theory is about. See, as scientists started knowing the different laws of gases, they got to know the laws of gases, laws, LAWS, laws. They kept on studying, further discovering, or further, with the study in deep of that particular concepts. Few came out with some theories which might have been valid at times, but later it might have found to be invalid. But at that particular time, that theory played a very important role for further studies. So that is why we are studying each and every concepts that comes under this, the main concepts we are studying. Next concept is about kinetic molecular theory of gases. Kinetic molecular theory of gases. I'll explain about this. Before that, for an introduction, now scientists wanted to explain how actually the gases behave, or how actually is the nature of gases, or how actually they do behave when they are put inside a container. This theory is very important, at the same time very easy if you have a proper picturization, you have your own imagination and to understand this particular concept. For 3 marks they usually ask this particular question. In chemistry, the maximum mark that you have is 3 mark. You can't expect a question of 5 marks directly. It is 3 plus 2, 1 mark carrying, that is 1 question carrying 3 marks, and 1 more question carrying 2 marks. You will have total 5 marks. So if it is asked for 3 marks, that means you will have to explain it whole. And this is one of that question which can be asked, most important one. See, molecular theory of gases. Now we generally know what are gases. Molecular theory means related to the molecules. Why the name kinetic? Kinetic means which is related to the motion. Kinetic molecular theory of gases. How are gases moving, or how are gases behaving inside a container when it is put inside? Or what do you get to know from that? So we will study one by one postulate from this particular concept of kinetic molecular theory of gases. So I want it to be done in a stretch.